Welcome to the boardroom. You are stepping into a high-stakes explainer where we treat Cambridge AS and A-level mathematics exactly like a Silicon Valley pitch competition. Today we are evaluating one of the most volatile, highly strategic, and heavily tested assets in your entire portfolio, Newton's laws and connected particles. We're talking about those complex, multivariable systems involving asymmetrical pulleys and inclined towbars. If you have ever stared at a mechanics diagram and felt your confidence completely crash, you are in the exact right place. My name is the Managing Director, and I evaluate exam structures with the strict, unforgiving precision of a Chief Technology Investment Officer. On the board behind me, you will notice our live grade valuation meter, currently tracking from $0 all the way up to a $1 million maximum valuation, mapping perfectly from baseline marking bands up to the elite A-star tier. Joining us in the war room today are two candidate founders who are trying to pitch their final exam answers to the valuation board. First, we have Alex. Alex is a highly technical developer who consistently overloads the exam paper with raw code, formulas, and isolated facts, but entirely lacks a cohesive, evaluative strategy. And second, we have Sam. Sam is a charismatic marketer who writes beautiful, flowing narrative paragraphs about the physics, but provides zero mathematical evidence, completely missing the strict command word constraints. Today, we are going to audit the Cambridge mark scheme, deconstruct their pitches, and build a structural advantage that will completely change how you secure your maximum grade valuation.
Director, let us pull up the Market Opportunity Brief. This is a direct quote from the official Principal Examiner reports. It explicitly states that this specific target area, 4.4 Newton's laws and connected particles, is a massive stumbling block for students globally. It is literally cited as one of the most misunderstood areas in the entire syllabus.
Director, my data architecture is solid. I have memorized every single iteration of F equals ma. I do not understand why my valuation keeps dropping when I execute the raw equations. Exactly. And my narrative is incredibly persuasive. I describe the tension, I talk about the friction, I make the examiner really feel the struggle of that tow bar pulling the trailer. Why isn't the board funding my response?
I will tell you exactly why. Alex, your raw data has no contextual application. Sam, your narrative lacks quantifiable proof. The board doesn't fund good intentions. The board funds structurally perfect compliance. Today, we are going to fix these exact vulnerabilities. We are looking under the hood of the examiner's expectations to give you the ultimate competitive edge.
Director, here is the strict, time-blocked blueprint we are using to capture maximum funding marks today. First, we will analyze the misunderstood mechanics trap and figure out why your current minimum viable product is drifting. Second, we will map the exact cognitive domains and assessment objectives the board actually cares about. Third, we will unlock the method mark strategy to capture residual process value. Fourth, we will deploy the evaluative thinking framework to scale your response to the top band. And finally, we will conduct a risk assessment of the top 3 examiner warnings. Let's initialize the sequence.
Director, initiating Phase 1, the misunderstood mechanics trap, a structural audit. Let's look at the live market risk chart. The primary reason we see such massive grade valuation crashes in student responses isn't a lack of basic mathematical capability. It's a failure in structural architecture.
Director, the valuation board frequently asks this exact question: why do candidates find applying concepts to unfamiliar contexts so incredibly difficult? Director, the logic gates are simple. I see a mass, I see an acceleration, I multiply them to find the net force. But the moment the exam paper introduces an asymmetrical pulley system, where one mass is hanging freely and the other is dragging across a rough horizontal plane with a coefficient of friction of 0.4, my algorithm breaks. The variables are too noisy.
And from a marketing perspective, the story changes entirely. Suddenly, it's not just a block on a desk, it's a car towing a caravan up a 12-degree incline while experiencing air resistance. I try to explain the physical struggle, but the examiners give me 0 marks for my situational analysis.
That is exactly the trap. Alex, you treat the context as noise. Sam, you treat the context as a story. Both of you are fundamentally misunderstanding what the board is asking for. The struggle isn't the raw math, and it isn't the narrative. The struggle is translating a highly complex, unfamiliar physical context into a rigorous mathematical model.
The answer to surviving this trap lies entirely in your theoretical architecture. Look at the data tracking on the board. The top-tier funding, the highest marks, goes directly to those candidates who integrate causal relationships.
You mean cross-compiling different syllabus modules?
Precisely, Alex. You cannot view this topic in an isolated silo. If you are calculating the tension in a towbar, you must actively connect Newton's laws with kinematics. You need the SVI-VDE equations to find the acceleration before you can even begin to build your force equations.
Oh, I see. So if the question mentions the system moving from rest to a velocity of 5 meters per second over a distance of 10 meters, I need to integrate that kinematic data into my force narrative to prove the causal link?
Exactly, Sam. Candidates who actively connect this topic with energy, work, power, and kinematics establish an unassailable model. That is how you prove to the board that you see the whole ecosystem, not just a single isolated line of code. Moving to phase 2. Cognitive domains and objectives, what the examiners want. To scale this pitch, we need to understand the exact cognitive domains the Cambridge Assessment Engine is actively targeting. Director, the syllabus strictly tests 3 distinct assessment objectives, or AOs. Let's look at the market risk chart tracking AO1, AO2, and AO3.
AO1 is my domain, knowledge and understanding. I can state Newton's first, second, and third laws with flawless syntactical precision.
And AO2 is where I shine, application. I can take those laws and write a beautiful paragraph about how they apply to the specific pulley system in front of us.
Both of you are only securing baseline funding. Yes, AO1 tests your core principles. Yes, AO2 tests your ability to apply them to a scenario. But AO3, analysis, is the primary driver of A-star valuations. Can you break down a complex system, isolate the specific forces acting on particle A versus particle B, evaluate the internal tensions, and systematically process that information into simultaneous equations? The examiners are running a live calculation on your performance across all 3 domains simultaneously.
Let's run a live simulation on a connected particles problem. Examiners issue a major compliance alert right here. Candidates consistently fail to establish precise definitions before calculating forces. I usually just bypass the definitions and start compiling the simultaneous equations. T minus m1 times g equals m1 times a. It's faster.
And I usually just say, the string pulls the block, and move on to the descriptive analysis.
Director, valuation crash. Both of those approaches immediately tank your score. If you don't explicitly define your system parameters, your entire mathematical model is legally invalid to the examiner. You must declare that the string is light and inextensible.
Wait, why is that critical to the code?
Because if it's not light, the string itself has mass, which changes the tension along its length. If it's not inextensible, it acts like a bungee cord, meaning particle A and particle B will have entirely different accelerations. By stating it is inextensible, you legally lock in a uniform acceleration metric across the entire system. And you must define the pulley as smooth.
To prove there is no friction?
Exactly, Sam. To prove that the tension metric remains perfectly uniform on both sides of the peg. Establishing these precise definitions up front proves your AO1 knowledge and immediately secures early valuation marks.
Director, Phase 3, the method mark strategy, capturing process value. This is where we look at how to capture passive income on the exam paper, even if your final execution string contains a bug.
In Cambridge Mathematics, the board awards crucial method marks just for your procedural flow. Think of this as getting paid for your operational efficiency regardless of the final product launch. Here is the exact standardized 5-step sequence you must deploy.
Step 1. Deconstruct the question constraints.
Step 2. Extract the relevant data arrays.
Step 3. Select the analytical framework, like deciding between a work energy model or a pure force model. Step 4. Execute with clear notation.
And Step 5. Present with correct terminology. This sequence is a non-negotiable compliance framework. If you hit a calculation error in Step 4, but your framework in Step 3 was structurally sound and clearly communicated, the examiner will still award you massive procedural funding.
But there is a massive caveat here. You must follow strict corporate presentation conventions to unlock those method marks. You mean my force diagrams need to be clearly annotated? I usually just scribble an arrow and write an F next to it. That is a severe compliance violation, Alex. Proper headings, correct terminology, appropriate mathematical formats, and perfectly clear annotation are mandatory. Your force diagram is your executive summary. If you have a normal contact force, label it R. If you have weight, label it mg, not just W. Show the direction of acceleration with a double-headed arrow distinct from your force vectors. If the examiner cannot seamlessly read the logic flow of your equations of motion, they cannot and will not authorize those method marks. Director, Phase 4, the Evaluative Thinking Framework, the A-star differentiator. We are about to look at the precise matrix that separates a medium-tier descriptive response from a maximum valuation A-star grade. But wait, valuation hold. Freeze the presentation deck.
Before we unlock this top-band paragraph architecture to completely scale your final grades, we need to optimize your educational asset flow. Take a second right now to subscribe to Ace the Exams and turn on all notifications so you never miss our weekly high-yield strategy drops, whether you are hacking exams at IGCSE, O-levels, or AS and A-levels. This channel is your premium encrypted pipeline to examiner logic. All right, system optimized. Let's get back to the pitch.
We are back online. Look at the comparison matrix. The absolute critical differentiator in your pitch is transitioning from a basic descriptive level to a high-tier evaluative level.
So a descriptive level is just me stating basic facts, writing down F equals MA, and solving for the unknown variable?
Correct, Alex. That is a baseline surface scan. It gets you partial funding, but it does not secure the market.
So an evaluative level means I need to question the underlying assumptions of the model, like asking what would mathematically happen if the Towbars suddenly snapped, or if the mass of the string wasn't actually negligible.
Spot on, Sam. An evaluative response actively considers different perspectives and, crucially, justifies every single analytical decision with hard mathematical evidence. If the question asks you to comment on the validity of a modeling assumption, you do not just say, "It makes the math easier." You explicitly state how the assumption of a smooth pulley allows you to equate the tensions, and you support that with the mathematical proof you just generated.
Let's run a live diagnostic on this higher-order compliance table. When tackling multi-part questions that require you to compare models, perhaps comparing a system moving on a smooth plane versus a rough plane, your analysis must be airtight.
Requirement 1. Identify similarities and differences. Execution. I will output the exact variance in the acceleration metrics.
Requirement 2. Use comparative connectives. Execution.
I will use structural terms like conversely, whereas, and indirect contrast to link the mathematical data into a cohesive argument.
Outstanding.
Requirement 3. Support all claims with evidence. You pull the exact numerical values from your previous calculations to validate your statements.
And finally, requirement 4. Draw conclusions about relative importance. You must definitively state which force is the primary limiting factor in the system. If you execute this structural matrix, your logic flow is unbreakable.
Director, Phase 5. Top 3 examiner warnings, risk assessment. I am now handing control over to the audience for a live compliance audit challenge. We are going to look at the specific compliance liabilities that cause candidates to hemorrhage the most marks globally.
Activating the rapid market scan. On the screen, you see a breakdown of the 3 massive traps highlighted in the principal examiner reports. The largest liability segment by far is using the wrong approach for the context. The second is forgetting format and presentation. And the third is submitting answers lacking specific context. Let's isolate these and trace exactly where the logic drops out.
Director, trap number 1. Using the wrong approach for the wrong context.
I do this all the time. I'll read a question about a particle sliding down a plane, and I'll immediately start trying to use the work energy principle, but I get entirely stuck halfway through because I don't have the final velocity data.
Exactly, Sam. You selected the wrong analytical framework. The context was screaming for a simple application of Newton's second law parallel to the plane, but your algorithm misfired. Or worse, Alex, what happens when a string breaks mid-motion in a connected particles question?
I usually just keep using the same acceleration value for the rest of the calculation.
Total valuation crash. The moment the string breaks, the tension becomes zero. The forces have fundamentally changed, meaning you must calculate an entirely new acceleration for the newly isolated particle. If your analytical framework doesn't adapt to the context shift, you lose all remaining marks.
Director, trap number 2, forgetting to check format and presentation. We are doing a live audit on a sample response now. Look at this medium-tier paragraph. The logic is somewhat there, but the execution is a disaster.
Yeah, that looks like my code. I dropped a negative sign on the friction vector, I didn't clearly separate my vertical equilibrium equation from my horizontal motion equation, and my final answer has about 6 decimal places.
And that is exactly where your valuation bleeds out, Alex. You are practically throwing away a high-value method marks. The examiner is not a forensic accountant. They're not going to spend 10 minutes hunting for your missing variables. You must present your equations cleanly, resolving vertically to find R, resolving horizontally to deploy F equals MA, and strictly rounding your final answer to 3 significant figures, as mandated by the corporate Cambridge guidelines.
Director, trap number 3. Submitting generic answers that are completely detached from the specific context of the prompt.
So, if the board asks me to explain why the calculated tension might differ from the actual tension in real life, I can't just write a generic sentence like, friction was ignored?
Absolutely not, Sam. That is a massive compliance liability. You must tailor it specifically to the exact parameters of the exam prompt. If the prompt is about a specific tow bar connecting a specific car to a specific trailer on a 15-degree incline, your evaluative statement must directly reference the mass of that specific tow bar or the air resistance acting specifically on the surface area of that car and trailer. Generic textbook definitions will be instantly rejected by the valuation board when they are demanding applied analytical context.
Director, Alex, Sam, you have successfully re-engineered your pitch architecture. The grade valuation meter has officially peaked at the maximum $1 million A-star score. To summarize this elite masterclass, we are locking in 3 universal rules in a final strategy checklist. Rule 1. Always define your terms and modeling assumptions before deploying your equations. Rule 2. Rigidly apply the 5-step procedural method to secure your process method marks, no matter what. Rule 3. Build a memory hack acronym to instantly deploy the structural factors affecting connected particles under high-stress exam conditions. And finally, rigorously execute past paper contexts so your logic algorithm is never surprised by an unfamiliar physical setup.
Listen closely. Understanding Newton's laws and connected particles is not just about memorizing a sequence of force formulas. It is about seeing the hidden mathematical matrix that dictates the physical mechanics of the world around us. If you can master the strict, unforgiving structure of this exam board, you can effectively master the physics of the entire universe. Your Series A funding is officially complete. Take a second right now to secure your educational equity. Subscribe to Ace the Exams. Aggressively click that notification bell for our weekly grade valuation masterclasses, and drop a comment down below sharing exactly which Cambridge subject and level, IGCS, O, AS, or A level, you are preparing to conquer next. Keep analyzing the data, keep evaluating your assumptions, and I will see you in the boardroom for the next explainer.